Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet with me, Richard here. Yes, we are having this question. It says that consider the following ionic compounds. These are the compounds we have: sodium chloride, potassium chloride, potassium bromide, calcium chloride, magnesium bromide. Yes, and we say draw Lewis dot diagram for each of the compound above. Okay. Yes, the first one, let us look at sodium chloride. So now we know that sodium chloride is made up of two elements. One is sodium, which is Na, and the other one is chlorine, which is Cl. Okay. Then we have to know that these two are going to interact through ionic bonding. So what do we start with? Let us start with sodium. Sodium belongs to group 1. So it means that it has one valence electron to it. So the easiest way out is for this one to lose an electron. So loss of an electron. When an electron is lost, what we get is going to be sodium without the electron. But because it lost the electron, it attains a positive charge. And what you see here is the Lewis dot diagram of sodium ion. Okay. Yeah, next we go to chlorine. Chlorine belongs to group 17, having 7 valence electrons around it. So it has 1, 2, 3, 4, 5, 6, 7. Okay. Yes. So this is what we have. Now, this atom has two choices, either to lose or to gain. If it is going to lose, it's supposed to lose all the 7. That's very vigorous. So the best option is to gain 1 electron so that it can become stable. Remember, all these atoms are fighting to attain stability. So what are we going to have here? We are going to gain 1 electron. And in gaining an electron, our chlorine atom previously, which is now chlorine ion, has this electrons distributed. This is 1, this is 2, this is 3, this is 4, 5, 6, and we have the 7. But it gained 1 extra more, which we put here. And with that, we need to know that it is conventionally acceptable to put a bracket here. We put a bracket, and because it gained 1 electron, it's negative, so the negative charge comes here. So in combining these two, what are you going to get? We are going to have our Lewis dot diagram of the sodium chloride as N plus, then chlorine with its 8 now, and a bracket around this one, and a negative here. So what we have here is the Lewis dot diagram of sodium chloride. Yeah, then we come to the one Lewis dot diagram of potassium chloride. we need to remember that this one is made up of two elements. One is potassium and the other one is chlorine. Okay, if you start with potassium, what do we know? We know that potassium belongs to group 1. Group 1 have 1 valence electron. Okay? So, the best option for this is to lose. So, it's going to lose that 1 electron. Loss of an electron. In losing an electron, we will have our potassium without the valence electron. But loss of an electron makes it to become positively charged. Okay. Okay, next we go to chlorine. Chlorine belongs to group 17, and group 17 has 7 valence electrons around it. So we are going to have 1, 2, 3, 4, 5, 6, 7. And for this one, the best option is to gain 1 extra electron to become stable. So we can put it here, gaining an electron. In gaining an electron, this is what we are going to have. We are going to have our chlorine atom surrounded by 1, 2, 3, 4, 5, 6, 7. But we need to remember that it gained 1, so it's now 8. And because it gained an electron which is negatively charged, it is negative. And conventionally, we are supposed to put a bracket here. So, and we put our negative here. So when you combine these two, what are you going to have? We are going to have potassium, which is positively charged, and our chlorine, this time around chloride, and we indicate all the surrounding electrons, 1, 2, 3, 4, 5, 6, 7, and the one it gained, which is 8. And we put the bracket around it with our negative charge. So what you have here is the Lewis dot diagram for potassium chloride. Okay, next we have potassium bromide. And we know that potassium bromide is made up of 2 elements, which is potassium, K, and bromine, which is Br. Okay, if we start with potassium, like we said before, potassium belongs to group 1. Group 1 has 1 valence electrons. And the best option for this group 1 to attain stability is to lose an electron, so loss of electron. When it loses electron, it becomes K without this 1 electron it has already lost. But because it lost an electron, it attains positive charge. So when you come to bromine, this is what you have to know. Bromine belongs to group 17, having 7 valence electrons. Okay? And what do? We can indicate them here. It's going to be 1, 2, 3, 4, 5, 6, 7. Okay? Yes. So, for this one, the best option to attain stability is to gain 1 electron. So we say gaining an electron. So if it gains an electron, it will become Br with the 1, 2, 3, 4, 5, 6, 7. And then the one it gained, which is here. Because it gained an electron which is negatively charged, it attains a negative charge. And conventionally, we are supposed to put a bracket here with our negative charge here. So when these two combine, they will form this, which is going to be K plus for potassium. Then our bromine coming with its C electrons, which is 1, 2, 3, 4, 5, 6, 7. And the one it gained, which is number 8. And what do? We are supposed to put a bracket here, and the negative charge comes outside. So what you see here is the Lewis dot diagram for potassium bromide. Yeah, then we come to calcium chloride. Okay, this one is made up of two elements. One is calcium, which is Ca. Another one is chlorine, which is Cl. If you start with a calcium, this is what you have to know, that calcium belongs to group 2. And group 2 has how many? It has 2 valence electrons. And the best option it has is to lose the 2 electrons. So we say loss of 2 electrons. Yes, why does it do that? To attain stability. So in losing the 2 electrons, what do we get? We are going to get our Ca without the 2 electrons which have been lost. But something happened. Losing the 2 electrons makes our calcium to attain positive charge, and is plus 2 because it lost 2 electrons. Yeah, next is to look at our chlorine. Chlorine belongs to group 17, having 7 valence electrons, which we distribute as 1, 2, 3, 4, 5, 6, 7. Okay, the best option here to attain stability is to gain an extra electron so that it can have an octet shell. So you say gaining an electron. In gaining an electron, this is what we are going to have. We are going to have our Cl, the atom, having our electrons as this, as indicated. Yes, those are 7, but we must remember that it gained an extra one. Okay, in gaining an extra one, it makes this one to be negatively charged. So we have a negative charge here. Now, this one is a bit different because you have to know that when you are writing the molecular formula of calcium chloride, we need to remember that calcium belongs to group 2 with valence 2, and the chlorine belongs to group 1 with valence 1. We have to remember that this valence goes here and this one comes here. So the exchange of the valence will create our molecular formula as CaCl2. So in other words, the structure we are writing has 1 calcium ion and the 2 chloride ions. And how do you present it with this? Because now we know the ions. How do you present it? This is what we do. What we do, we have our calcium ion with its 2 plus. Then on one side, we bring our chloride ion with its constituent electrons around it. We have to remember that there is a bracket here with negative. And also this side, we have our Cl, okay, with its constituent electrons, which is 1, 2, 3, 4, 5, 6, 7. and that extra one which came in to make it negative, and you put a bracket around it indicating the negative charge. So what you have here, this one, is the Lewis dot diagram of calcium chloride. Yeah, then lastly, we come to this magnesium bromide. Okay, this one is made up of two elements, which is magnesium Mg and bromine Br. Okay, so let us look at magnesium first. Magnesium, the symbol is Mg, and it belongs to group 2. Group 2 has 2 valence electrons around it. Okay, so the best alternative to attain stability for group 2 is to lose those 2 electrons. So it's going to lose, so here we say loss of 2 electrons. Okay, after loss of 2 electrons, what are we going to have? We are going to have Mg, which is our magnesium symbol. But after loss of 2 electrons, it became positive. And it lost 2, so the pole is 2 plus. Okay. Then next is going to be our bromine. Bromine belongs to group 17 with 7 valence electrons around it, which we can indicate as 1, 2, 3, 4, 5, 6, 7. The best choice for this to attain stability is to gain 1 electron. So here we can say gaining an electron. Okay, in doing so, what happens? We are going to have our bromine with our electrons surrounding it as 1, 2, 3, 4, 5, 6, 7. But we have to remember that it gained 1 more, so it is there. And in gaining an electron, what happened? It attained a negative charge. So it's conventionally we're supposed to put a bracket here with a negative charge there. But now we need also to know something which is very important here. That when you're writing the formula, the molecular formula for magnesium bromide, we say magnesium is group 2, so it's valence 2. And bromine is group 17, valence 1. So remember, these are supposed to exchange the valences. So this one goes there, and this one comes here. With that, what do we get? We have our formula. The formula is going to be MgBr2. This is the formula. So in other words, what we are going to have in our Lewis dot diagram, we are going to have 1 magnesium ion and 2 bromide ions. Okay, and how do we arrange that? This is what you have to do. You have your magnesium with the ions. Okay, and then you bring your, on one side we put Br, which is our bromide ion. But you have to remember that it has 1, 2, 3, 4, 5, 6, 7, plus that one which it gained 8. And because it gained that one, it's now negative. So we put a bracket and negative. Even this side, we put our Br with its surrounding electrons, which is 1, 2, 3, 4, 5, 6, 7. But we have to remember it gained 1, so we put it there. And that one it gained made it to become negative. So how do you indicate that one? You put a bracket and you put the charge. So what you have here is the Lewis dot diagram of magnesium bromide. And with that, I would like to say thank you for your time. The channel is PSSB, Physical Science's Silver Bullet with me, Richard, here. We urge you to subscribe, to comment, to like, to share. Yes, we believe you will not regret. See you next time. Bye-bye.